In this video, we're going to use the formal definition to prove that the limit of x squared as the x approaches 2 is going to be 4. Okay, so first, the definition. And first, we're going to work with this part here. So our goal is to express delta in terms of epsilon. First, we're going to take x squared minus 4. So notice that the absolute value of x squared minus 4 can be expressed as the product of x minus 2 absolute value and x plus 2 the absolute value. Okay, so now notice also that x minus 2 absolute value is less than the delta. Okay, so that means that you multiply both sides of this inequality by the x plus 2. So if you do that, that means it's going to be less than this part, the delta times x plus 2 absolute value. Okay, so now we can assign, so we can have delta absolute value x plus 2 less than epsilon. Okay, so now where does that lead us? It says that so that the delta is less than the epsilon over absolute value of x plus 2. Notice I'm just solving for delta in this inequality here. But the problem is that, first of all, delta is less than the epsilon over absolute value of x plus 2, but also delta cannot be a variable. All right, it has to be a constant, so that epsilon must be divided by a number. To find the constant, we're going to first say that the delta is going to be less than 1, right? Because delta must be sufficiently small but positive, right? So we're always going to assume it's less than 1. So that means the absolute value of x minus 2 must be less than 1. And where did I get that? I got that from here, right? So if delta is less than 1, then definitely this absolute value of x minus 2 must be less than 1. Okay, so now where does that lead us? Notice that this can be actually expressed as negative 1 is less than x minus 2 is less than 1. So I'm letting go of the bars by just writing this inequality, absolute value equality in terms of two sides, two boundaries, the 1 and the negative 1, so that the bars are out. All right, so, and namely, we can just add 2 on all three sides to get 1 is less than x is less than 3. Okay, so this is going to be helpful because our goal now is to get to x plus 2, right? Because our goal is to eliminate this variable and to make a constant, possible constant, instead of just add 2 on all three sides. So if you add 2, it's going to be the same as having 3 is less than x plus 2 is less than 5. Okay, now if you notice that the x plus 2 absolute value must be in the denominator, right? So we have to take reciprocals. Now, if you take reciprocals, 1/3 will be actually greater than 1/5, right? So you have to switch the placement, right? So it's going to be 1/5 is less than 1, and let's take the absolute value of x plus 2 just to make sure we get a positive, is less than 1/3, right? So now, what that means is that we can multiply the numerators of these three by the epsilon, right? So that means the epsilon over 5 is less than the epsilon over absolute value of x plus 2 is less than the epsilon divided by 3. Now this leads us to conclude that we can actually find a constant that we were trying to derive. So we can set delta being less than or equal to epsilon over 5, right? Because if delta is less than the epsilon divided by absolute value of x plus 2, that means delta is going to be the same thing as the epsilon over 5. I mean, we can't set that, right? That's possible to set it equal to or less than. Okay, so that means what? Such that absolute value of x minus 2 is less than delta, and what does that mean? We can just set that the absolute value of x minus 2 is less than, and we already found the delta in terms of the epsilon, which is epsilon over 5. Okay, so that's great. So now let's get to this part again, right? Because our goal is to start with this and end with the epsilon being to the right of the less than sign. Right, so we're going to say thus x squared minus 4 absolute value is equal to, and then again we're going to express it as a product, x minus 2 absolute value plus times x plus 2 absolute value. Now notice that x minus 2 absolute value was less than the epsilon over 5. So if you multiply both sides by the x plus 2 absolute value, you will get less than epsilon over 5 times absolute value of x plus 2. Okay, so again, multiply both of these sides of the inequality by the absolute value of x plus 2. You're going to get this on the left side, and you're going to get this on the right side. Okay, now notice what we can do here. We can actually replace x plus 2 absolute value with a 5. Now, why is that? We're going to just compare the absolute value of x plus 2 versus the 5. Notice that we have it right here. X plus 2 was less than 5, right? So naturally, if you multiply the epsilon over 5 by the absolute value of x plus 2, it must be less than the epsilon over 5 multiplied by 5 to hold up this inequality there, right? So what does that do? In turn, that cancels out the fifths, and it makes sure that we get epsilon in the end. So we've satisfied starting from the absolute value of x minus 4, which is here, less than sign, which is that, and then the epsilon sign right there.